So in the inference engine, basically an inference engine cycles through three sequence steps. So first one is match rule, as we have seen in our previous slide, then selection rule and execute rule. So basically the execution of the rule will often result in a new fact, or you can consider as a goal, which being added to the knowledge base, which will be trigger the cycle to repeat it. Okay, so this cycle will continue until the new rule can be matched. So basically the inference engine use a particular procedure and rule by the inference engine, in which it is to be considered a particular solution to get a particular answer, and we can able to match that up to what, up to a new rule can be matched. So for the purpose, in the first step, which is nothing but the match rule, the inference engine finds all the rules that are triggered by the current content of the knowledge base. So in we can see here in the forward chaining, the engine looks for a rule where the that particular consideration is going to be carried out, which applies for a particular we can consider it as a applies rule repeatedly to the facts which are obtained from earlier rules application, and add new knowledge into the knowledge base if required. So basically what exactly we are doing here, we are just matching that particular rule, and in the second step we are selecting the rule according to the inference engine prioritization. And in that, if it is to be considered the final step, so final step is what, to execute the rule. So the engine executes each match rule in order to determine in step, which is to be required in the step 2 is what, in step 2 we are considering to find the, or we can say the select the rule. So in the step 2 we have to get execute that rule, and the engine execute each match rule in order to determine in step 2, and then it will uh, go back to the step 1 again. So that means up to what part it will be go, it will be considered up to the cycle is continue until the no new rule are matched. So for the purpose, if I want to find this particular strategy in the form of considering the interface engine, then we are considering here, or you can consider the recommendation solution by using either by forward chaining or by backward chaining. So let's understand this concept with the help of forward chaining. So basically the forward chaining is considered as a strategy which is to be required for expert system to answer the particular questions. So why this happened basically? So this is to be given with the help of the particular forward chaining. So in this particular forward chaining, basically it begins with the information that is already accessible, and then uses the inference rules to extract the more information. Okay, so here the inference engine follows the chain of the condition and derivations and finally deduce the outcome. So it consider all the facts and rules and sorts them before the concluding a solution. So basically what exactly we are doing here, basically for a particular user, from a particular user or for a particular instance, until the goal is attained, it goes up to that part, up to that particular solution we are concluding. So it clauses the particular rule which is considered as a true condition. The inference engine using the forward chaining will explore the inference rule until it finds one that does. So when such a rule is discovered, the engine can draw a conclusion or deduce the logical conclusion, that is we add the new rule. Say for example, suppose that the goal is to be conclude the color of a pet, which is considered as the name of the pet. If I'm going to consider as uh, Fritz, okay, so the name of the pet is Fritz. Given that he croaks and eats the flies, so and that the rule base contains the four rules. One is that if the X croaks and the X eats flies, then X is a frog. If X creeps and X sings, then X is a canary. If X is a frog, then X is a green. If X is a canary, then X is a blue, like that. So the strategy which is going to be followed to working on a particular result, or to get a particular result, which is to be considered here in the form of some facts. So let's illustrate this particular forward chaining by particular example where we have to consider the pattern, and then we have to evaluate with the help of rule. So what exactly the facts is that? The facts we have to consider here, that the pet name is, if I'm consider Fritz, Fritz croaks. That means it eats the flies. So with the forward reasoning, the inference engine can derive that the Fritz is a green in a series of steps. Since the base facts indicates that Fritz croaks and the Fritz eats flies, that consider the rule 1, that is satisfied by the considering that X is crocs and X eat flies. So that X is a frog, like that. So that's why my concluded result will be nothing but Fritz is a frog. Basically, this is exactly the rule which is going to be applied according to what we are going to consider. So the name forward chaining comes from the fact that the inference engine starts with the data and the reasons it waits to answer. So in that, it will work in the particular direction. So that is to be nothing but according to this fact 1 and fact 2, that ending will be considered and then decision will be takes place. And in the facts 3 and facts 4, the ORing will be considered, then decision will be takes place, and then both finally will be combined, and the final decision will be get access. That means the strategies is to be applied for this particular rule, which is to be get carried out according to what type of conclusion we are getting. So this is basically a forward chaining. Backward chaining work opposite to basically the forward chaining, which works in the way it is considering the strategy as an expert system finds out the answer to question, that is why this happened, like that. So for the purpose from why to, that is how it is to begin to carry it out. So on the basis of what has already happened, the interface engine tries to find out which condition could have happened in the past for that particular result. So this strategy is followed for finding out the cause or finding out the reason. So basically, if I'm considering some evaluating, or if I'm finding a particular person is having a that particular disease or not, that is to be given with the help of this particular forward chaining. So what is the rule for this particular representation we have to carry it out, that is to be given with the help of rule for knowledge representation. Before going to start with this, I just want to add few steps how a forward chaining steps is to be carried out. So in that, if this particular will be happens, then that will be get carried out. That means if then rule can be used to represent the knowledge. If it is rains, then you will get wet, like that. If A then B can be expressed as A slash B. So here A is called as that particular intentions, and B is called as a consequent of that particular A. So the rule can be also be recommendations. If it is, then it will be like that. So if it rains, then you should wear a coat. So the rule for knowledge representation has to be considered with the help of, again, forward chaining, or we can consider a conflict resolution, meta rules, and backward chaining. So basically, the rule for the knowledge can be represented with the help of some facts, in which we can represent some rule-based production system, and in that we have to apply the production system. So what is exactly mean by production system? Is a system that uses the knowledge in the form of rules to provide the, or we can provide a diagnosis or advice of a particular basis on which we can get the data, that is nothing but the input data. So that system consists of a database of the rule, which is nothing but the knowledge base, the database of a facts, and the inference engine which reasons about that particular fact to use that particular rule. So here we have seen the forward chaining in a particular example, if I want to see, which is given in the form of data driven system. So basically, in this particular step, the system is given one or more than one constants. Then the rule are searched in the knowledge base for each constants, and the rule that fulfill the condition are selected. That means if part. So now each rule is able to produce new condition from the conclusion of the invoked one. That means whichever the condition is satisfied. So when a fact matches, then it will be rule will be get triggered. Then the rule is fired and the conclusion is to be takes place from that particular fact. So here I given one example to consider the rule that it used to control an elevator, and that is to be given for 3-story buildings. Then the rule one is what? If on the first floor and the button is pressed, then it is in the on the first floor. Otherwise, then it is open the door. And the rule two is what? If lift is on the first floor and the button is pressed on the second floor, then go to the second floor, like that. So that is basically where we are added the condition which is to be going to proceed again by repeating the step. So that means the rule which is to be going to apply, then the process will be end if there is no new condition exist. So it is called as a rule-based system, also commonly used as a knowledge-based system, expert system, and artificial intelligence. So what exactly the rule-based system? So basically a rule-based system, or we can consider as a knowledge-based system, are specialized software that encapsulate human intelligence like knowledge, and they can make intelligent decisions like that. So that is comes under rule-based system. So what are the keywords we have to consider here, which is nothing but what exactly the quick decisions are going to be carried out. If I want to repeat that particular task again, then is that repeatable? Is that knowledge is going to be applied, and according to that, is the condition is going to be satisfied? So understanding the knowledge which is to be given with the help of facts. So in that we have to understand the factual knowledge, sequential knowledge, and logical knowledge. So in that we have to consider what comes under the factual knowledge, that is nothing but the facts, what exactly the data we are having, and information. For example, if I'm considering the employee data, then what is the what exactly the information about that particular employee you had to consider, then that is to be given with the help of knowledge, so represented in the memory of a computer. So basically that is to be considered as the properties of the forward chaining. So in that we have to understand the process which uses basically this if I'm considering the forward chaining, then the process uses a down up approach, that is nothing bottom to top. It starts from an initial state and uses the facts to make a conclusion, and this approach is data driven. So for the purpose, we have to understand the things which is to be required for the this particular forward chaining. So in that we have to consider two types. One is nothing but forward chaining rule, which is nothing but data driven or deductive approach, and another is nothing but backward chain ruling, which is nothing but goal driven and which is having some inductive approach. So in that we have to consider in the forward chaining, we are considering the if it's employed in expert systems and production rule system. And in the backward chaining, if I want to understand what are the steps which is to be required to go for the forward chaining, then the first is in the first step the system is given one or more than one constraints, then the rule are searched in the knowledge base for each constraints, and the rule that fulfill the condition are selected, that is nothing but if condition, matlab if part. And now each rule is able to produce new condition from the conclusion of the invoked one. So that means every time it is to be get added, and as a result then part is again included in the existing one. So for the purpose we have to understand which condition we have to accept according to the rule to be get fire on checking the condition as well as goal. So the addition condition are processed again by repeating that particular step, which is to be required nothing but then rule are selected in the knowledge base part, and from the constraint for each constraint, and the rule that fulfill the condition are selected. The process will end if there is no new condition exist. This is actually based on the forward chaining. And what we have to consider in the backward chaining, in which the steps which is to be required for the backward chaining, where backward chaining is a concept in artificial intelligence that is to be invoke backward backtracking from the endpoint of a goal to step that lead to the endpoint. So this type of chaining starts from the goal and moves backward to the comprehend steps which is to be required that were taken to attain that particular goal. So what are the steps here? First, the goal state and the rules are selected where the goal state resides, and in then part are then which is to be given in the form of conclusion. So from the if part of the selected rule, the sub goal are made to be satisfied for the goal state to be true. So in that we have to understand which is to be true state we have to consider. So set initial condition important to satisfy all the sub goals, which is to be get added for each condition, and that is to be getting backward way to find out the rule. So verify whether the provided initial state matches with the established state which is to be get executed. So if it fulfills the condition, then the goal is a solution, otherwise the goal is the not solution. So we have to consider some conflict which is going to be applied for resolution strategies. And then we have to again select the rule to fire, and if it is a fire rule is found, then we have to consider each rule condition recursively and with the condition as a goal, and all the recursion is returns true, then we have to consider that is a one or more goal fail, and we have to check for the new match. So this is all about backward chaining. So when I consider the current state of the rule-based system, then why they are not widely used? Just because of there is no standard language for the rule definition, as well as the considering the huge learning curves in a vendor specific rule language, where we had to understand, we have seen that what exactly mean by production system, and in that we had to consider the rule engine still considered to deal with the metadata, not that particular exact data. So which whatever the purpose we are going to performing some rule based system, that is to be not carried out, and that's why they are not using some such a type of systems in the AI. So there are some examples I have mentioned here for the usage of rule engines. One is in Dell, Cisco, Vodafone, Blue Cross Blue Shield Insurance. These are all the real examples of usage of real engines.